Hello everyone. Today I want us to look at how to integrate the square root of x squared plus 4 with respect to x. So in this case, we are going to make either trigonometric or hyperbolic substitution. So this is what you do. Let me explain why. You see, when you factor out 4 from the square root sign, this integral can now be written as 2 times the integral of the square root of 1 plus x squared over 4 dx. I have factored out 4. So 1 plus x squared over 4 is like I want 1 plus which function squared gives us the other function squared, either trigonometric function or hyperbolic function. So I want us to take note that the hyperbolic cosine squared of theta minus sine hyperbolic squared theta, this should always give us 1. So I want 1 plus what? 1 plus something squared. So this, if I take it to the right hand side, I am going to get that 1 plus sine hyperbolic squared theta is the same as cos hyperbolic squared theta. So if you look at whatever is under the square root sign, we can now do the comparison. We have 1 plus x squared over 4 is equals to something. So when we compare the left-hand side, we have 1 and 1, you compare, those are the same thing. So we can as well say that x squared over 4 is the same as sine hyperbolic squared of theta. So from here, we conclude that x squared over 4 is equals to sine hyperbolic squared theta. So therefore, x will be equal to 2 sine hyperbolic of theta. So that is the substitution that we need to make. This is hyperbolic substitution. So let's find the derivative. What is dx d theta? So we are going to get 2 cos hyperbolic of theta d theta. When you differentiate sine hyperbolic theta, you get cosine hyperbolic theta. So we go back to our integral. So this integral can now be written as, and that is equals to, that is, we can write, let's work with the given integral, the first one, before we rewrite. So this given integral can now be written as equal to the integral of the square root of x, our x squared, that is now 4 sine hyperbolic squared theta plus 4. Then dx the same as 2 cos hyperbolic of theta d theta. So I can factor out 4 from the square root. So I'll get 2 times the integral of root sine hyperbolic squared theta plus 1 times 2 cos hyperbolic theta d theta. But sine hyperbolic squared theta plus 1 is cos hyperbolic squared theta. And the square root of that is cos. Let me repeat, sine hyperbolic squared theta plus 1 is the same as cos hyperbolic squared theta. And this is under the square root, so that will give us cos hyperbolic of theta. So this equals to 2 times the integral of cos hyperbolic theta times 2 cos hyperbolic theta d theta. 2 times 2, that is 4. So we'll have 4 times the integral of cos hyperbolic squared theta d theta. So we now need to know how do we integrate cos hyperbolic squared of theta. So we need to rewrite that as cos hyperbolic of multiples of theta. So take note that we are going to write that NB, we said cos of 2 theta is the same as cos squared theta plus sine hyperbolic squared theta. But we know sine hyperbolic squared theta, so this is the same as cos squared theta plus sine hyperbolic squared theta is the same as cos squared theta minus 1. If you look at this identity, let me take it from here, we can make sine hyperbolic squared theta the subject, so we get cos hyperbolic squared theta minus 1. So, and if I combine those cos hyperbolic squared theta, we get 2 cos hyperbolic squared theta minus 1. So I want to make cos hyperbolic squared theta the subject. So that means I'll add 1 on both sides and then divide both sides by 2. So you can say therefore that cos 2 theta plus 1 is the same as twice cos hyperbolic squared theta. So when I divide by 2, I'm going to get cos hyperbolic squared of theta is 1 over 2 cos 2 theta plus 1 over 2. So that's what I'll now integrate. So, but remember that was multiplied by 4. So if I multiply by 4, so or 4 cos squared theta will simply be equal to 2 cos 2 theta plus 2. We are multiplying by 4. Why by 4? Because you see the 4 that was a constant here. So this integral, what will it give us? So therefore, this integral will now be equal to 2 times the integral. Of course, 2 is common. So I'll have here as cos 2 theta plus 1 with respect to theta. And that will give us 2. What is the integral of cos 2 theta? What did you differentiate to get cosine hyperbolic of 2 theta? It was sine hyperbolic of 2 theta, and then this is over 2. Then when you integrate 1, you get theta. And remember, there's a constant c of integration. So therefore, I want to replace theta. So we go back to where we defined theta. Let me take you back to where we defined theta. And you see from this equation where x is equals to 2, 2 sine hyperbolic of theta. So you can make theta the subject from here. You get that theta is equals to, now we are going to divide by 2, then take sine hyperbolic inverse on both sides. So it is sine hyperbolic inverse of x over 2. So that is our theta. Now we go back to our solution and substitute the value of theta. So our answer here will be equal to 2 times, of course, let me open the bracket before when I substitute. It's better to open the bracket. Remember, we are multiplying by 2. So when you multiply by 2, this is what you'll get. You're going to get sine hyperbolic of 2 theta plus 2 theta plus c. Even before I replace theta, remember another identity. Take note that sine hyperbolic of 2 theta is the same as 2 sine hyperbolic of theta cos hyperbolic of theta. So that our answer can now be written as 2 sine hyperbolic of theta times cos hyperbolic of theta, then this plus 2 theta plus c. But what is 2 sine hyperbolic of theta? Look at our substitution. We said x is equals to 2 sine hyperbolic of theta. So this is equals to x. Then we have times cos theta plus 2 theta plus c. So I need to replace theta. We said theta is sine hyperbolic inverse of x over 2. So before I replace theta, I can also replace cos, because I know sine hyperbolic theta is equals to x over 2. Let me write here so that we see, all of us see. Take note that we are saying sine hyperbolic of theta is equals to x over 2. So what about cos hyperbolic of theta? So cos hyperbolic squared theta is the same as 1 plus sine hyperbolic squared theta. So therefore, cos hyperbolic of theta is simply the square root of 1 plus sine hyperbolic squared theta. So our answer can still be written as x times the square root of 1 plus sine hyperbolic squared theta, then plus 2 theta plus c. And I know sine hyperbolic theta to be x over 2. So even here I could have written this as the square root of 1 plus x over 2 squared, that is x squared over 4. And so when you substitute that into the answer, we are going to get is equals to x times the square root of 1 plus x squared over 4, then plus 2 theta, 2 sine hyperbolic inverse of x over 2, then plus c. So that is our answer. And you see, you can factor out 1 over 4. If you factor out 1 over 4, we are going to get this. It will now be 1 over 2x times the square root of 4 plus x squared plus 2 sine hyperbolic inverse of x over 2, then plus c. So that means the integral, remember what you are integrating, it was the integral, let me use a different color, the integral of the square root of x squared plus 4 dx. So our answer is 1 over 2x times root of 4 plus x squared plus 2 sine hyperbolic inverse of x over 2 plus c. C there is a constant of integration. So thank you all for watching. When we meet next time, we look at other forms of integrals. Bye bye.